Welcome back again. In this section, we are going to look into another component of Hyperledger Fabric, which is ledger. So, ledger stores important factual information about the business objects or assets. Ledger consists of two parts. First is world state and the blockchain, which is nothing but the transaction log. The world state can be stored in two databases. First option is LevelDB, which is the default database, and you can also improve it to CouchDB. So CouchDB, or if you have CouchDB, you can run complex queries, which we will see in the practical section as well. The ledger is the sequenced, tamper-resistant record of all the state transitions in the fabric, while state transitions are a result of chain code invocations or the transactions submitted by participating parties. Each transaction results in a set of asset, which is key value pairs, that are committed to the ledger as create, update, or delete transactions. So the ledger is comprised of blockchain, which is why it is called blockchain, which is a block of chain, to store the immutable sequenced record in blocks, as well as the state of the database to maintain the current fabric state, which is the world state. There is one ledger per channel. Each peer maintains a copy of the ledger for each channel of which they are a member of. Ledger features. So query and update ledger using key-based lookups, range queries and composite queries can be done on ledger. Read-only queries using a rich query language, that is, if you use CouchDB as a state database, you can run read-only rich queries on that. Read-only history queries, which is query ledger history for a key, enabling data provenance scenario. So all these functions, all these query or query history, so you are going to see it in the practical section where you run, where you write the code for each of the transaction. So transactions consist of versions of key or values that were read in the chain code, which is called read set, and the key and values that were written in the chain code, that is called the write set. The transaction contains signature of every endorsing peer and are submitted to ordering service. This we have already seen in the ordering service. Transactions are ordered into blocks and are delivered from an ordering service to the peers on the channel. So peers validate the transaction against the endorsement policies and endorse the policies. So basically, peers, when peers get the transaction, it validates the transaction against the endorsement policy, which will be defined for every peer. So you will see the definition how we are going to define the endorsement policy in the coming section. So the peers will validate these transaction against those policies. Prior to appending a block, a versioning check is performed to ensure that states of the assets that were read have not changed since chain code execution time. There is immutability once the transaction is validated and committed to the blockchain. A channel's ledger contains a configuration block defining policies, access control list, and other pertinent information. So this information you can see in a configuration file in the lab section. Channels contain MSP or membership service provider instances, allowing crypto materials to be derived from different certification authority. As we know, to talk to the network, every entity who is participating in the network should have a certificate, authorized certificate, which is provided by the membership service provider. So those certificates are used. So you can picture ledgers like this. Consider P1 as the peer, and it has S1, which is a set of smart contract, and you have another S1 and you have S2. So you have one set of smart contract and you have one ledger. You have another set of smart contract and you have another ledger. It may occur that there exists a smart contract and you don't have a ledger. So this is about ledger. In the next section, we are going to see the properties of another component, which is channel. Thank you for watching.